Fractional distillation of crude oil. In an oil refinery, the crude oil has to be separated into fractions. A fraction is a group of hydrocarbons with similar boiling points. These separations happen in huge fractionating columns. The various components of crude oil have different sizes, weights, and boiling temperatures. So the first step in the process of this is to separate the different components of crude oil. And because you want a fraction with similar boiling points, because a fraction is a group of hydrocarbons with similar boiling points, you want to have components in one fraction which have similar boiling points, but at the beginning of fractional distillation, they have different boiling points. So they can be separated easily by a process called fractional distillation. And the steps of fractional distillation are heating the mixture of two or more substances, which are liquid, with different boiling points to a high temperature, and the heating is usually done with steam in the columns of the factory case. Like if you were to go to a crude oil refinery, you'd find fractionating columns, and the heating would take place with high pressure steam. And the mixture then boils, forming vapor, which are gases, and then the vapor enters the bottom of a long column called the fractional distillation column that is filled with trays or plates, and those will be explained later. And the vapor rises in the column, and as the vapor rises through the trays in the column, it cools. And so basically trays have many holes or bubble caps, and in them they allow the vapor to pass through. And these trays also increase the contact time between the vapor and the liquids in the column. And these trays help to collect liquids that form at various heights in the column. And there is a temperature difference across the column. So you will find hotter temperatures at the bottom and cooler temperatures at the top. So this basically means that the larger hydrocarbons with the high boiling points turn back to liquids nearer the bottom, and at high temperatures there, the smaller hydrocarbons stay at gases, so they rise up the column. And so the different fractions are now condensing at different points. So after the vapor rises through the trays in the column and cools, it'll condense to form a liquid when the substance has reached its boiling point equal to the temperature of the column due to the vapor. So yeah, like I said before, the substance with the lowest boiling point will condense at the higher point in the column, and the substance with the higher boiling points will condense lower in the column. And so then these trays also collect the various liquid fractions, and then after this, the trays with the collected liquid fractions, and the liquid fractions would be passed on to storage tanks, which would cool them further or go to other chemical processes. And so basically, when you look at a fractionating column, you will see that first you will have at 40 degrees the refinery gases, and then, so basically, for example, the refinery gas would have smaller hydrocarbons, so which means that they are more up in the column. And then after refinery gases, you will find gasoline, also known as petrol. And then after that, you will find kerosene, and then diesel oil, also known as gas oil. And then at 400 degrees, oh no, wait, just before you'll find fuel oil. And then at 400 degrees, so fuel oil is around 360 degrees, and then bitumen is on 400 degrees, which is the larger larger hydrocarbons. So yeah, that is pretty much how oil refining works. Thank you.